Hi all. Just waiting for everyone else to join. Let me see who has joined already. I think Rohit has joined. Hi Rohit.
Hello.
Hello. Let me just share my screen. Okay, right. Long time, I understand. Let me see here. I've just shared it. Are you able to see?
Yeah, I'm able to see.
Okay, give me 1 minute. Oh, okay. So there was this typo. I was just running through whatever we did until the last time, right? So okay, so just let's do a recap. So what we were doing is that until last time we imported a data set, right? And then we started looking into each and every column, right? We did some exploration of the data, right? And this is to do an income kind of prediction. Okay, we are trying to predict the income. Now, uh, the outcome variable is like less than equal to 50K or greater than 50K. And then we started looking into the data, right? We looked into the null values and so on and so forth. Then we converted the categorical variables into numeric ones, right? So after we have done that, we started doing this test train split, right? Then we divided the data into X and Y, which are the features and the targets. Then what did we do? We employed a decision tree classifier. Now, when we employed a decision tree classifier, there was one parameter which we mentioned, and that parameter is related to max depth. Okay. Sorry, because of some network issue, I got disconnected. Let me reshare. Uh, can you hear me now?
Yeah, I can hear you now.
Okay. Until what time did you get what I was saying?
Well, you were telling from the starting that what we have done in the previous classes, and then it went off.
Okay. Okay. Give me 1 minute. Okay. So what we are going to do now is that we looked into creating a decision tree, and we created a decision tree using a default parameter which is max depth. We explained very briefly that max depth is the parameter by means of which we control, right? We control what is going to be the depth of the tree. We also verified the version of scikit-learn because we wanted to check the documentation. Now we fitted the model. We know what metrics we need to check for. We have to check for the confusion matrix, and we have to check for the accuracy score. Now there is something I should tell you about what to use at what point in time. I'm going to do that now that we stopped at this point in time, right? So I'm going to tell you what to do and what not to do now. So let me just go back to my original data from where we did the data split. So X and Y came from DF, right? X and Y came from DF. So DF is my original data frame. So if I do a DF head, just for 1 minute, I'm going to do a DF head. If I do a DF head, I'll get the original data frame from where I broken down the data. Now here I have this income field, which is my target variable. What I'm going to do, I'm going to take this income field, right? And then I'm going to do a value counts. Okay, I'll tell you why I'm doing this value counts. So if I do a value counts, I come to know what is the kind of, let's say, ratio, right? What is the ratio between the positive cases and negative cases? So negative cases is where zero tag was given to people who have less than 50K. Okay, so let me just write it over. Zero means less than or equal to 50K salary, and one means okay greater than 50K salary. Okay, one means greater than 50K salary. Okay, and zero means less than equal to 50K. Now you can clearly see there is a class imbalance, right? This problem is a very common thing in any practical machine learning kind of a scenario. In any practical data science scenario, this is a very common thing. What we call this is known as a class imbalance. Now the class imbalance, you can clearly see that there is a ratio. Okay, so this ratio is really bad. I mean, if you do 7508, divided by 22654, you see the kind of, let's say, ratio to the positive class over to the negative class, right? So we will just assume that my positive class is where my salary is greater than 50K. These are like people earning quite well. And I have my negative class, which is like the less than or equal to 50K, which are not as comparatively that much having as an earning, right? So compared to to the negative class, the ratio is really big. So, and again, you can clearly see what is going to be, let's say, df dot shape. If I do, I have 30,162. So if I do a zero, this is the number of rows, right? If I divide this, okay, if I divide this, no, I mean, I take a numerator of 7508. Okay, so it is only 25%. So 25% of my data, right? 25% of my data denotes one class, while 75% of the data denotes the other class, right? This is the point which I wanted to make. Now, keeping this in mind, accuracy score is not a good thing to look at. Okay, this is the ground rule. Because statistically, it can be proven also. Why is this the case? Is because we can relate this over to the conceptual things we learned when we looked into central limit theorem and when we looked into empirical rule. What we were doing in case of central limit theorem and why we were going back from time to time to a normal distribution, or in the applied sense, why were we selecting more and more samples, is because higher the number of samples, lesser is the probability of my distribution not being closer to normal, which means more the sample, more it is likely that my distribution will be close to normal. And hence, if more my distribution is closer to normal, I can put a leaf on my eyes, and I can clearly say that I can put the empirical rule in place, right? So I can put the empirical rule of 68, 95, 99.7. That's the rule, right? Sigma plus mu plus minus 1 sigma explains 68%. Mu plus minus 2 sigma explains 95%. Mu plus minus 3 sigma explains 99.7%. That this rule is the standardized rule. So to apply any standardized rule like the accuracy is a standardized rule. Why is that a standardized rule? Because what we are doing in case of, let's say, accuracy, okay, is as simple as this. It is as simple as this. So it is like, you see how many data is there. So it is the accuracy is calculated as 6467 plus 1145. Okay, now I'm going to take a copy of this. 1 minute. I'm going to take a copy of this, come over here, plus 1145 plus 309 plus 1128. Okay, if I execute this, I get the exact same value. You see, accuracy score is 84.12, 0.8412, sorry, and accuracy score over here is also 0.8412. Right, so that is the calculation. How did I do it? I added up the diagonal elements. I added up the diagonal elements. So these are the correctly identified points divided by all the number of points. So that is the accuracy. But this accuracy score, because it is a standard measure, it's actually wrong in this case. Why? Because I have a class imbalance. So that is the reason why this is a very, very important point. We should always keep this in mind. We should never ever use accuracy score as a measure unless and until we have very good balance of both the classes, right? Let's say I have very, very good balance of both the classes. Okay, so let's say I have 55% of one class and 45% of another class. This is not really an exact 50-50 split, but this is brilliant, right? I mean, I'll even go with the 60-40. In case of a 60-40 also, let's say I have 10 examples. 6 are the positive examples, 4 are the negative examples. It's all fine, right? It's all fine. I can still go ahead with the accuracy score. I don't need to do anything else. I'll only look at the accuracy score and I will be deciding how good or how bad my model is. Why are we doing this now? Just to set the stage. We have already done the modeling part earlier also. We have created some of the models earlier, right? We have created the linear regression model. We have created the logistic regression model. We overall understand what we need to do while to create a model, right? We have got the flow, right? I hope you have no doubts with the flow, but let me just quickly explain what we are doing in the flow. So let me take a pen. So we are starting from here. Let's say this is our start. Okay, in this start we are actually defining the problem statement, right? We have already defined the problem statement. Okay, then so what do we do? Oh, this is not the right way. I mean, okay, let's go ahead with this. Maybe I'll actually write this down and I will be sharing it with you. Okay, I will write it down and share it with you. So first we will do a start. We will be asking the question over here, or we will be defining the question what we want to answer over here. Then what we are going to do, we are going to collect the data, or we are going to select the data, right? Once we are done with select the data, then we are going to look at the data description. Okay, we are going to look at the description of the data. We are going to see what the data means all about. And herewith, we are also going to perform some statistical tests. We are also going to do some EDA, right? We have not done a lot of EDA over here. I mean, strictly speaking, we should have done things like probability density function and cumulative density function also. If you remember, we did those when we looked into iris data set, right? We took that iris data set and we looked into PDF, CDF, and so on. We did not do this in our case, but we should do that because that will answer a lot of questions. Once that is done, then what we have done, we have done the data transformation, right? We have converted the categorical variables into numeric variables. Maybe in our data there was a column which was a date column represented as a string column. We have to convert it into string, or we have to convert it into date time, I'm sorry. So that kind of transformation will be done. One hot encoding, label encoding will be done, and so on. Once that is done, then I'm going to select a machine learning algorithm. In this case, I started with the decision tree. Later we will come to know that it is not about selection. What I said is actually incomplete, but I'll anyways write that as a selection. Okay, why I'm calling it a selection, although this is wrong, right? This word itself is wrong. What we do ideally in the industry as well, that we select, let's say 10 to 20 models which we know, and we select those models basis the complexity of what we need to deliver. Example given, quite soon we are going to see that it is really very easy for me to explain a decision tree. The real reason why people use or start with the decision tree is because it is very easy to explain. It is so easy that I can actually draw a graph and I can explain that to you. I'm going to draw a diagram, and from the diagram I can explain that to you. A bit of calculations we have to do because we have converted some of our let's say categorical or the string columns into numeric columns, right? uh, Give me 1 minute. Yeah, I'm back. Okay, so after we have selected a machine learning model. So what I mean by selection of the machine learning model is that rather than applying one model, ideal condition in the real world, we don't apply one, we apply, let's say, 20 models. Okay, we take one data set and we apply the 20 models. As of date, we don't know 20 models. When it comes to classification or use cases related to classification, how many models have we seen? This is the second one which we are looking at, right? We looked into logistic regression earlier, that is a classification model, but it can only classify the binary classes. Decision tree can be extended actually. Decision tree can be extended to look into both the binary as well as the multi-class kind of thing. Now we do this kind of, let's say, modeling for multiple number of times. We select multiple types of the models. Once we have learned all of them, then we can use all of them, right? One after the other, we use all of them. We validate whether our model is performing good or not, or which model is really performing good, using some of the techniques that I'm going to teach you today. After which we come to a conclusion. Okay, I have fit 10 models. I've fit 10 different models or 10 different variations or 10 different algorithms. Finally, I select X algorithm because it is the most prominent with respect to whatever criteria or whatever KPI I select to define the goodness of the model, right? It's the same thing which I said when I talked about the accuracy score also. Just give me 1 minute. Yeah. So when I talked about the accuracy score, what I was saying is part of this. We were looking into. We are not going to look into accuracy score in our case because what is happening is we don't have a balanced classes, right? We don't have set of balanced classes, right? But if we had, we could have used. Yeah, so no problem. Then after the selection is done, what do? We can also do optionally. Okay, we can also do before even doing the selection, we can do the data standardization on the or kind of the normalization. Okay, we do the normalization of the data or the standardization. Let's say we are going to do let's say scaling of the data. That is what we have done earlier, right? After that is done, we select each and every model, and for each and every model, what have we done? We have selected the test and train splits. We have divided the data into training and into testing sets, right? And then we have actually uh, calculated the metrics of the model. So, for example, what we have done, we have taken some kind of a metric, right? We have taken some kind of a metric and we have calculated the score of the model. In our case, in my example, what have we done? We have taken both the accuracy score as well as the confusion metric, right? So that is what we have calculated here. We have taken the confusion metrics as well as the accuracy score, right? So these are the scores that I have actually calculated. After I have calculated the scores, I don't stop there. Now what I do the hyperparameter tuning. This is what we are going to do today. Okay. I do the hyperparameter tuning. This is where I get the best set of parameters, which results into the best set of model. This is the score that I have selected. Obviously, in my case, I have not selected the accuracy score. Accuracy score is not going to be the right one for me, right? What may be the right one for me is this confusion matrix. Again, we can talk about precision and recall once more, right? We can take precision and recall, and we can see how good or how bad my model is basis the precision and the recall. How much we are able to increase the true positives and true negatives, right? As opposed to looking at the accuracy only, or we are going to look into how much we are able to get in form of precision and recall, and that is going to help us understand how good or how bad the model is. Right now, once we have done that, we do not stop there. Obviously, in our case, we are going to stop here, right? We are going to stop here. But what we do again in the industry is that we can continue from here. We create a model file. We actually convert this model into file. I will also show you how to do this, but at a very later stage. After we have done some of the algorithms, right? Then I will show you. Then what we do, we put this into production, which means we create some kind of a web application or a desktop application, and we power that app. Okay, we power that app by this model file that we have created. So, for example, let's say I have created some GUI. Okay, I've created some GUI where there is a text box and there is an upload button. Right? I input my data. Right? I have to prepare my data, input my data with the same columns as I have in this example of mine, and the user is asked to upload it over here. He or she clicks the upload button, the data gets uploaded, right? The moment it gets uploaded, I get a button over here, or the user gets a button over here. Click on the predict button. The moment you click on the predict button for that one row that I have inserted, also in the backend I can do the validation how many rows are inserted. If multiple rows are there in the file, I'm going to give an error and say no, I'm sorry, you have to give only one input and so on. Or maybe rather than doing a file upload, I can also do, let's say, a series of text boxes for each and every value of each and every feature. And the moment the user clicks on the predict thing, my model file will be called, right? The model is ready, it is saved, the patterns are saved. This button click action is going to call this model by passing these inputs which user has given in the front end, right? The moment I get back the prediction, I show it on the screen. Okay, so your I see basis these features or these values, there is a so-called so and so probability, or I'm 100% certain, I'm quite certain that this person is going to have a salary which is greater than the 50K rate, right? So this kind of an application we create. Now what we do when we creating this application, in the back end we collect the logs for this application also, right? So for example, every time this kind of an operation is done by a customer, right? Every time the customer enters the values, this kind of a button is clicked, right? We take the logs. And the reason we take the logs is to understand how my app is working. Also, how good or how bad the prediction is over a period of time, right? Over a period of time, how good or how bad my uh, prediction is. Is it like my prediction accuracy is increasing over a period of time? Because in the back end, this entire process of modeling and training, this entire thing, right? This entire thing is a cyclical thing, right? I may be doing this every week. Every week once at least I'm going to retrain my model with new data, with new data, with new data, and so on. So every week I'm going to have a new model file deployed in my app. And then I'm going to compare week by week what is going to be my accuracy. Is it increasing like this? Or I have a model performance, let's say accuracy is my KPI, and my accuracy is actually decreasing over a period of time, even if I am retraining my model from time to time. So this is bad, right? This is a very bad thing. Something is wrong with my model. I'll go back and I'll see wherever I have done any mistakes and so on, right? So this is like the collection of logs. I have to collect all the data of this application. I may even visualize this, like the examples I showed you over here, using operational analytics tools like Splunk, or let's say visualization tools like Tableau or ClickView. I'm going to visualize them, right? I'm going to visualize them every day and come to know, okay, this is how my model is really performing, or even more so, this is how my app is really performing. Let's say it is taking 10 seconds for a user to get the prediction. It is okay. I mean, the user can wait for a 10 seconds. What if that 10 seconds increases to 60 seconds because of some issue, right? Because of some problem that is increasing to 60 seconds. Will my user wait for a minute to get the prediction? Maybe, may not be, right? Then the authenticity of my app is going to get really a challenge, right? So 60-second may not be a good thing for me. 10 second is really acceptable. These kind of parameters I'll have to define, and uh, keeping them in mind, I'm going to do the logging and the monitoring by the application itself, right? We are not going to touch this part. I'm sorry. We are not going to touch this part. We can do this. I mean, I can tell you the libraries which you can learn in Python. It is very simple. There are libraries like Django. There are libraries like Flask, and you should be able to do this. If you want, I can share you sample code. That's all I can do, right? But looking at the sample code, you will really get to know what is happening here. I have some sample applications. I can share that at a later stage, and you will understand how it goes, right? I hope it is clear until this time. So this is what we are going to do. Now we are at this stage. We have got some scores. We'll still look at, let's say, precision and recall, and then we are going to do hyperparameter tune. So until this point in time, are things clear to you?
Yes.
Yeah. Okay. Let's try to visualize the graph. Actually, I have uh, forgotten how to do, but let's see. From sklearn matrix import precision uh, precision score, the precision score and recall score. So I'm going to do precision score, and I'm going to pass y test y thread. Y thread is not defined. Y. Oh, okay. Y thread default. Sorry. Y thread underscore default. And this is going to, my precision is this, and my recall score is what? If I do sorry, if I do a y test y thread default, then my recall comes to be 50. Now, what is my recall and what is my precision? I hope you do remember, right? So precision is greater means wherever the model said, or wherever my data said this is a positive class label, the model was able to predict this as a positive class label. So how many positive class labels were identified as positive, right? So if I have given it a training data with 10 positive class labels, how many has it really correctly identified as the positive ones? Now, the recall score is like the balance between the positive and the negatives. How many positives have we identified amongst all the identifications that we have done? So clearly, my model is really not that good. Okay, it is really not that good. I have 80, close to 80% of precision score, which is good, but I don't have a good recall score. This should be in a balance, right? I should not have this kind of a high or low thing. However, there are cases also, if we'll later see, where one value needs to be greater than the other, because basis the kind of question we are trying to answer, right? There can well be a scenario where I'm more interested in higher recall as opposed to higher precision, because there can well be the case that let's say I'm looking for fraud and not fraud into any banking transaction. Specifically, if I go and tell the customer this is not a fraud operation, it's not really exciting, in the sense that this does not give me any opportunity to help improve the business. If it is a fraud transaction, that is actually really what I'm looking for. Right? The statement is really bad, but if you look at it from a practical point of view, I would be actually more interested to classify the wrong things or the fraud transactions properly, because the more I classify them properly, more I can make my system better. Right? That is the objective. So let's say I'm working in a bank. My objective is to detect the fraud transactions being done by fraudsters on the accounts of my customers. My objective will not be to say to the customer, see, sir, we have 85% of the transactions which are not fraud. That's not my case. My stand should always be, what about the rest 15%? If I'm able to correctly identify the rest 15%, I can do something to actually improve the situation. That is the objective. In that case, things will change. Precision and the recall is not going to be the same, or we are not going to consider equal weightage for both, right? But we are going to look at those cases later on. This is a very simple case. Here we don't have that kind of a complexity. So now what we need to do is that, uh, let's see if I can do something. So what I'm going to do, from I Python dot display for image, right? Yeah, image. I'm just trying to remember and do so. This might take some time. I have actually forgotten now. Externals dot 6, I believe. Import. These are simply libraries in Python where, okay, sklearn externals dot 6 is not there. Import string IO from sklearn. Oh, yes, yes. String IO should not be imported like this. But let me see what we are doing here. Find dot plus. Very good, very good. Where did it import string IO? From IO. Okay, okay. Good. From input output, import string IO. Good. Well, let's see if that works. I don't know. So now what I have to do, from sklearn.tree import graph. Uh, I'm trying to press tab to see. Oh, no, no, no. It was export underscore graph. Yes. Export graph visualization. And then I'm going to say import py dot plus and graph. No module name py dot plus. Very good. So I will do pip install py dot plus. I'll give it a minute to get installed. Once it is installed, then we can do the visualization. Or most probably, to save time, what we can do is that we can carry on with hyperparameter tuning and we can visualize the graph later on. So maybe let's see how much time it takes. If it takes more than 2 to 3 minutes, I'll skip. Your internet connection is unstable. Are you still able to hear me, Rohit? Because it is giving me a note
Yeah,
over
yeah, I
here.
can hear you. Yeah, I can hear you clearly.
It's installed. Let's see if this works now. Okay. No. So the graph is, I think it is done. Give me 1 minute. So, yeah, come over here, press and enter. Yeah, this works. So I'm going to delete this. And now what I'm going to do is I'm going to put the list of features in one column. Do I have that? I don't think so. X dot columns. Yeah, I have this. So what I'm going to do, I need a list. Okay, so I'm going to put this in the list. You will come to know why I am doing this. Okay, so what I did is that I imported 4 of the modules. One is going to give me the input output capability or string to be written inside an image. Then I need a library to display an image because I now want to display my decision tree as a picture, right? It's in the same way as we drew earlier, right? Using that example which we saw, play or not play, which we calculated in Excel. Then I need to import a library, actually a module, or actually here I have imported 3 modules to do what? To export the visualization, so that I can even export the visualization into, right, into something else, right? So what I'm going to do now is that, let's say, if I'm able to do this, but I need a graph viz. I need graph viz. So let me download graph viz. Close this graph viz hyphen 2.8. Let's say zip download. I have to download this. If you are working on Windows, right, you have to download. Okay, you have to download Windows. Table Windows install packages. Why? Um, okay. No. no. Yes, of course. Windows 10. Yes, yes, build, release, 52. Yeah, I've got one. Let me just save this. Save as, within some kind of a directory. You may not be seeing that screen there, Rohit, so don't worry. I've only shared my IPython notebook. That's why you are not able to see the rest of the screen. Actually, putting it into our folder, uh, learning data science, Telegram group study, supervised learning. Last folder is today, and I will put it over here. And I will go to this folder, go in folder, and I'll do an X. Sorry, I will do 7-zip extract. Done. I have done the extraction, and I have graph this inside that, and I have bin. Okay, so what I'm going to do now is that I'll come back over here, import os dot list dir, and if you see, I have this folder now. So what I'm going to do is that I have to set my path. In Windows, this is what we need to do, or otherwise we don't have to do anything. Okay, we don't have to do anything. So what we have to do is that I have to os dot set path. I believe. No, os dot environ. Sorry, it was environ as far as any, yeah, environ, and here I can set the path. So path should already be set. So I can print the path like this. My path is set already. Now in this path, what I would like to do, I would like to append. Okay, so I would like to do plus equal to os dot path set. Okay, os dot path set is the path separator for this OS. So it is going to by itself do the calculation. Then I'm going to put my installation path into strings. Okay, so I'll take this and put it over here. So this is the path where I've actually put it, right? This is in my C users document teaching folder, and there I have this bin folder, right? So when you download this, right, from your site, please change it according to wherever you unzip the GraphViz thing. So you can download GraphViz, extract this, take the path until the bin folder, and then you have to put it over here. Okay, take the path until the bin folder, and then you put it over here. But there is a small problem in here. I just noticed that. Okay, so let me just correct that problem. The problem with Python is it does not recognize that slash. So I have to replace that slash. So what I need to do, I'm doing it on a notepad separately, and I have to replace that slash with forward slash. So replace all close, and here copy, come over here, home, from here until the end. I do a paste. Okay. So now I have my os.environ. If I print the path, I should have that. Yeah. I have that at the end, but did I did it, let's say, correctly? I'll have to see. Okay, let's see. I think this is the right way to do, but let's see. If we get an error, we will change the direction of that slash, and we'll see. So what we installed over here is the GraphViz library, and the reason why we did that is because it does not recognize the diagrams out of the blue or out of box. Unless and until you have that with folder, it does not do that. Now what I have to do, I have to create a variable. Usually we call that dot data. Okay. And you will come to know why it is called the dot data right now. And it should be an object of string IO. This dot data is going to contain each and every nodes in my tree. And how I'm going to do that is that I'm going to call that export graph viz thing that I have imported. I'm going to pass a few parameters. The first parameter I have to pass is DT default. So this is my model, right? I have to print my model. That's what I'm here to do. My out file, okay, this is a temporary out file, and the temporary out file will be created in the same path only. So dot data is going to be my temporary out file. Uh, Feature names. I have to give the list of features. Now to give the list of features, I have already taken it into features, right? I have taken that into features, so I'm going to give it over here, features, right? And then I'm going to use an option called field equal to true. Field equal to true means in each and every node, okay, I'm going to have the mathematical numbers also. So in each and every node, I'm going to specify the impurity, number of samples, and so on and so forth. So we will talk about impurity when we see the value. We have not really talked about it. We only talked about entropy and information gain. So entropy is one of the measures of looking at the impurity. There is one more measure also. It is called Gini coefficient. Okay, we will look at it. Okay, so don't worry. And then I want the squares to be rounded. This actually looks good. So this combination is something which I use, which looks good. Okay, that's all. There is no other reason. Now I want to plot a graph which takes pi dot plus. Okay, pi dot plus is a library from where I'm going to do graph. Okay, from dot data, I believe. Yeah, graph from dot data, and I'm going to pass that uh, this file. Okay, so this is the file that I'm going to pass. Okay. Let me see if dot data is created. No, it is actually created into memory. So dot data dot, I have to do dot data dot get value. Okay. I do a dot data dot get value. It has created my graph. Now I have to visualize my graph. And to visualize my graph, what I do, I call that image function, the one that I imported, and I do graph dot create PNG. PNG is a good format because it is small, so it will load quickly. I can also do create uh, JPEG. I mean, but JPEG file size is usually bigger, right? So that's why uh, it takes more time to load. Even this one is taking good amount of time. I don't know. I believe that is because of the nodes in the tree. Let's wait for 2 minutes. Let's wait for 2 minutes. Ah, yes, we have got the tree. So this is the visualization of the tree. Now you see how easy it is, because now what I can do, I can actually right click, open this image in a new tab, and I go to that new tab and I will be able to explain my image to anybody. So what is happening over here? Is this the right way to open? Yeah, we can do that. It's not an issue. So what we are doing over here is we are checking the relationship value. Okay, relationship might be a categorical value, right? A relationship may well be a categorical value. So you have to convert that into this kind of a format. So you have to understand it by this format. If relationship is less than or equal to 0.5, this is my root node. The relationship has what? Highest information gain basis my decision tree. So basis the tree that I have created, relationship variable or relationship feature has highest information gain. That's why it is selected. There is a Gini coefficient also. Okay, there is a Gini coefficient also. We'll talk about the Gini coefficient when we talk about it into depth, right? But as of now, we have taken these many samples, 2, 1, 1, 1, 3. The values are divided like this. Okay, and from those samples, what we have found out, relationship less than or equal to 0.5. This is a categorical, this is a dummy encoded variable. So most probably we'll have to convert this value back to text. So that is what you need to do, right? When you are going to explain this to any client or to any manager, that manager will not understand what is relationship with less than or equal to 0.5, right? Less than or equal to 0.5, that manager will not really understand. You have to convert that. So you have to decode the value and then you have to explain this. If it is less than equal to, then true, it goes here. Okay, on the left hand side it goes. Let's look at the left hand side. On the left hand side it goes. If it is true, then it is checking education num. This is also number of the number given to the education. Is it less than or equal to 12.5? It is true, then it is going here. Is capital gain less than or equal to 5095? If yes, again it is checking education num. Right? Again it is checking the education num. And then it is checking hours per week. Then it is finally giving me a block. Now, how do you read this block? Is that if you look at the leaf node, right? If you look at the leaf node, you can also give the target to variables here. If you give the target variables here, that becomes easy for you to understand. Okay, that becomes really easy for you to understand which block means what. But usually what happens is it is divided into two colors. The warmer color, okay, the warmer color is usually the uh, one value, and the blue color is usually the false value. So 1 and 0 is divided like this, right? Else there is also a way to pass the value. Let me just think about it. Let me, I mean, yes, we may need that because that is going to be a good way to explain things, right? But how do I give that value? Let me Google. I'm not able to remember. So what I'm doing over here is uh, visualize. Okay, let me first of all do one thing. Let me give you this link first. Okay, let me give you this link first. I hope you're on your laptop only. So please have a copy of this link. I'll also note it down and I'm going to put it into my notebook too. Let me just put it into my notebook. So I'm going to do insert cell above and do mark down. Come on, man. Why is it so slow today? Mark down and from below URL we can download graph is extracted in any folder and update. Right, that's what we have done. Right. So after that, what I need to find out, let's do a googling. In Google, I have to find so class labels in decision tree picture. Let's see if this gives. Okay, visualize a decision tree in 4 different ways. Very good. This guy is saying I can do it in 4 different ways. Yeah, I can do it using text also. This is also one really very good thing. I just want to do this. I actually forgot this. This is a really good thing. dt.default export text is not there. Why is it not there? Export text should be there, right? Oh, oh, um, so that, sorry, control Z. This would be tree and from skill learn import. Okay, now I have to CLF should be DT default. I made a mistake there. Yeah, now I have got this textual, let's say, representation. Now this is even more better, right? I mean, you can read it as a text. You can even save it as a text. So you just have to map it back. The only drawback of this textual representation is it gives like this: feature 10, feature 2, feature 3. You have to map feature 10 back to, right? You have to map it back to the feature. Or most probably there will be some options over here. Let's see. Feature names is feature names. What one? Right. Yeah, I got this. So relationship less than 0.50, that's the root node. Education num being this, capital again, this education num again, hours per week is less than equal to class 0. Okay, so less than 50K salaried employees are where relationship is usually they are, let's say, bachelors. I'll assume it is done in the right order. They have less education, they have less capital gain, and they are also putting less hours per week work, right? Even if the hours per week changes, then also their class does not change, right? Their class only changes when they have a capital gain of this. Okay, when they have a capital gain of this, and then their age is also playing a very important factor here. You see, here. Once we take into consideration age, then only the class changes, or otherwise the class was all the same. Even if they are lower than or equal to and greater than or equal to 35 years of age, it really doesn't matter. The moment you go beyond or in the range of, let's say, 3550 to 6150, then your class is equal to 1, right? But if your age is more than that, and if your occupation code is more than 2.50, occupation code, why I am saying is because occupation was a textual field, it converted it into a numeric field, right? So this is the way you can explain the model also, right? You just have to convert the categorical variables into the numerical formats. I hope you got the point, right? But let me go back over here. I wanted to do something. Yeah, class names. Yes, this is what I wanted to do. Class names is this. They have used the iris data set. I will not do. I will. Where did it go? I think it is here. Feature names is this, and then I have to put class names is this. And in class names, what I'm going to do? Go to create a list. Okay, class name should have two values. One is less than equal to 50k, another is greater than 50k. Okay, let me visualize the graph now. Okay, okay. Mm, there is some mistake that I'm doing. What is the mistake? It shouldn't be a list or what? Okay, let me put it into brackets. That is not going to be a list. No problem. No, it's still not giving me the outcome. I'll actually figure this out, Rohit. There's something class names. Why not look at it? This is where this is export graph base, graph base class name. Okay, let's see how it is used. So if I come over here, ah, they are still using this kind of a methodology. I don't know. Okay, class names I have over here. Okay, list of strings. Yeah, so that is what I passed. So what is the problem? I passed a list of strings only, right? Mm, let's see this. Lot of googling we have to do. I don't know why this page. Only. So okay, class names is equal to true also. Okay, very good. Very good. No, it says no object between. I don't understand. It was working 2 minutes before. I did this and then it stopped working. Why? Maybe. Yeah, done. Open image in new tab. I'll close the earlier one and this time it should give me the class. Yeah. Okay, it gives me the class. You see, y0 is the orange ones and y1 is the blue ones, right? So class 1 is the blue one, or the positive one is blue, and the negative one is the E0 class. So that is a good way in which we can understand, right? I hope you have got the point, right? I hope you have got the point. This is a good way to understand what is the importance of doing a decision tree. So clearly, we have quite easy representation, right? We have to agree that we really have quite easy implementation. Now we don't have much time, but I would like to go through the hyperparameters, right? Hyperparameters I'll have to explain, and then we can go ahead and we can do a technique which is known as grid search. Okay, we are going to do a technique known as grid search. Okay, and then we are going to find out what is the best hyperparameter required. Okay, or what is the best hyperparameter really required. So what I'm going to do, sklearn decision tree classifier. So we will go through the hyperparameters as of today, at least the important ones, right? And then we will do the coding part in let's say tomorrow, right? Now, the first one I'm going to skip. We have looked into what is entropy. We have calculated what is entropy. We have not looked into Gini. The Gini measure is something I'll have to explain you. So that's what I'm skipping right now. I'll need some time to explain this. This will take at least 10 to 15 minutes. So that is why I'm skipping this. But by default, to fit any decision tree, it uses Gini using sklearn, right? Using sklearn, if you fit a decision tree classifier, by default, it uses the impurity measure as Gini. Okay, it's also known as Gini impurity or Gini value or Gini scale and so on, right? So these are just the different names. Now, it is a function to measure the quality of the split, similar to entropy, right? Where I have more entropy, I have less information gain and vice versa. I need to look for cases where I have maximum information gain, right? That's what we studied in case of entropy. From there, we got the information gain. And from the information gain, what did we do? From the information gain, we have to find out the best split, right? Now, the next parameter is known as splitter, right? Now, how am I going to use this? Now, splitter is actually something which we really don't use much, but it is good to know what splitter means. Splitter means the strategy we choose to divide the data. In the other words, what is going to be the sampling strategy? Okay, this is not the strategy. Okay, this is not the strategy to select uh, uh, the column basis which we are going to do the division of the node. For example, I have this node n1. I want to divide this into two, or it gets divided into two, into node n2 and node n3, right? If it does that, then splitter does not decide this column. This column is actually decided by the entropy or information gain and the measure of the criterion that we have used, right? But what we are really deciding is how much samples will go over there. For example, if I have 1000 samples, how many comes over here, how many comes over here? Now you might be wondering, this is a logical thing, right? I mean, if it is true or if it is false, then it goes to these sides and it is automatically calculated as the strategy or as the splitter. But uh, split uh, here in this case, in this context, splitter is also going to mean how much we can, let's say, make this node pure, right? So how much samples we should be selecting so that or how am I going to do the splitting so that I have as much purity as possible, right? So that's the way we are going to do the splitting. That is controlled by this. Default is best. We can have best, we can have random. Then we have max depth. This is something that we have used. I've used a max depth of what? Tree size 5. I've used 5, which means my tree will not go more than this value. So I have this root node and then 1, 2, 3, and 4, right? If you look at my diagram also, if I go back to my diagram, you see this is 1, 1, 2, 3, 4, 5, right? So I have 5 stages to which it can go. So uh, this is the zeroth node, 1, 2, 3, 4. Oh, I'm sorry, one more has to be there, 5, right? So at max 5 I'm going to do other than the root node. So after the root node, 5 levels I can go. That's max step. I selected 5, right? We have to understand each and every one of these. Unfortunately, we don't have time now, so we may have to close. But we have to understand each and every one of this. And what we are going to do then is that we'll take a combination and permutation of each and every value which is possible in these hyperparameters. And then we find out, okay, we find out a set of the parameters. We set of the parameters which gives me the maximum performance in my model. So let's say in my model, let's say the KPI for deciding whether it's a good model or not is the accuracy of the model. So whichever combination of these hyperparameters results into the highest accuracy is what is going to be my selection. Or in my case, if I'm looking for a balance between precision and recall, whatsoever combination gives me a good balance between precision and recall is going to be, right, my finding, right? How am I going to do that? I can do this manually, right? This one, let's say, let me delete this. This can take two values. This can take two values. This can take infinite number of values, right? I mean, the numeric one, because this is an integer, it can take any value. So I'm going to consider, let's say, I'll only take three values. I'll take only three integers. Then again, this can take infinite values. I'll take only three. So you see how many combinations I'm going to have. 2 multiplied by 2, multiplied by 3, multiplied by 3. These many models I'll have to build, right? These many models I'll have to build. 4 multiplied by 3, 12, multiplied by 3, 36. I have to build 36 models. And I have to find for each and every model what is the precision, then what is the recall, and what is going to be the accuracy score. And then I decide, okay, model number 21 is the best. And model number 21 has so and so value for these four hyperparameters. This is one way I can do. The other way that I am going to use is a technique which is known as grid search cross validation. What grid search cross validation will do, I'll write a single or 2 to 3 lines of code. It is going to do this activity for me. That's all, right? Rather than me doing it in a manual way, I'm going to ask a library to do it for me, right? So let's continue from there in the next class, right? I hope there are no doubts as of now, Rohit. So
No
we
doubts.
can close. Yeah. Okay then. Then let me stop the sharing. I'll be sharing the things, right? So let us continue same time tomorrow. Thank you so much.
Thank you. Good night.
Thank you, Rohit. Good night.